Okay, hi everyone. Uh, I'm Waleed Ashraf. I'm Node.js Foundation Community Committee member. I work in Berlin as a Node.js developer at Relayer, and I'm from Pakistan. You can follow me on Twitter at WaleedAshraf01. And yep, uh, today we are going to talk about switching from cluster module in Node.js to PM2 and RabbitMQ. We'll also talk about how can you break down a big monolithic app to microservices and look forward to move to a serverless architecture if you need. So this comes from the migration we did in my previous company. And I'll guide you about some steps, some tips you should remember if you are moving through the same process. So all of you know about Node.js. I'll just ask a question. How many of you are Node.js developer? Yeah. So you already know it's single-threaded. This is how it looks like. Very fancy, simple, elegant, and fast process. You can do anything you want. But the problems come when you run it in production. This is how it looks like. It becomes a mess, and you get it when it explodes in production. Yeah. So there are a lot of problems, and if you notice with time, there's a kind of a monster inside if you don't manage it properly. So yeah, you can tweet it. So the problem is that Node.js is a single-threaded, you all know. So if you're running an app which is CPU intensive, it will take at least one core of your machine, consume it more. So it will maybe degrade the performance of what you can achieve with Node.js overall. The rest of the cores of your machine will be doing pretty much OS-related stuff. Now, the OS does handle these things very efficiently, but still you cannot take the full advantage of Node if you're running it on a single thread in a single instance. What we want to achieve with Node is to split it up with multiple threads using cluster modules so that we can split the balance in the machine. And maybe later on, you don't even want to use this. It's totally depend on the use case, and you can see and monitor what's the performance of your machine and the service. So in the talk, we'll talk about how you can split different entities in your big monolithic app. Like if you're using SMS, you're using image processing, you're sending some email notifications. How can you take out these individual chunks from your big app to a separate service? And then maybe on one of them, you can deploy on AWS Lambda or Azure Function to manage it separately as a Lambda. So let's talk about cluster module. It's a built-in module in Node.js, which provides you which you can take child processes. And if you run the HTTP app, it will share the same ports. You can split the traffic. It has no shared memory. You have to manage it your own if you are communicating, if you're trying to share memory between different processes. But it has a IPC communication, inter-process communication, where you can send messages from the master process to the child process, and so on. So let's start with tear down. We have to separate out the individual chunks of app which can be a separate service. This happens in a lot of different companies. It was same for our use case, that the SMS, emails, and image processing are part of every big company, and if it's a monolithic app, this can be taken out individually. So we start with creating a cluster module, and you see in the top, I check if it's a master process. When you start, there's only one master process. If it's a master process, we take separate forks for SMS, email, and image worker to separate out our logic. And I'll explain with the whole code. You'll get it. That in the next step, we do a for loop, and we iterates to the number of cores that the CPU have, and we create process for HTTP. So for the loop one, the forks are for the HTTP communication. The request comes in, and they can redirect to, they can go to one of the workers, and the forks for the SMS, email, and image workers are to separate out the logic of the individual fork. And there's a tiny mistake in this slide, if anyone can point out in the loop. Let's see. If you know. So it's kind of an implementation mistake that if you do loop to choose your total number of cores, we'll have 3 less than 4. If it's a 4 or a 7-core, 8-core machine, it will be 7 number of process for the HTTP communication plus 3 more for the SMS, email, and image. So total there would be 10, and that's more than the actual cores on the machine. So you don't want to do that. You always want to put like minus at least less than number of cores or less than the number of cores you are going to consume. Okay, so the other thing we want to do is to handle the disconnect and the error, like if the server crash, if the fork crash, we want to restart it. To do that, there's an event disconnect on the cluster module itself. You can listen to it, and you can restart the cluster. That's what we're saying we're doing here. If we see if there's a disconnect event, we log it, and we restart a worker. This is for HTTP. And now comes to the communication between the child process and the master process. So in the else block, we introduce 3 global functions where we can send the message from one of the fork to the master process. You see, I have global.sms.send, global.email.send, and global.image.send, where I'm sending the message, the email, whatever the message is, to the master process. And I'm also introducing a type so that I can separate them out later on. These messages are going from the fork process to the master process. To listen to these messages on the master process, we introduce same message on the cluster module in the master process. We listen on the worker.own message. Whenever you receive a message, you'll check it, if it's SMS, email, or image, and then you can send it to the relative worker, which we introduce on the top. So, and if you're wondering about how the image SMS worker itself looks like, it's just like a single file or whatever your implementation is. They listen to the message, and then they can do whatever you want to do in the process itself. Like if it's an SMS worker, you can receive the message, you can receive the data, and then you can use Twilio or whatever service to send the SMS. You can separate out your implementation. So how does it look like in a big scale is that we have app workers, depending on the number of the cores we have, and then we have SMS, email, and image, and maybe you will have more workers separate out. Then we put the cluster module provides the master process. We put it in the center, and we send the relative messages from the app forks to the master, and then master sends it to the relative workers. So it's like the master process sits in the center and manages the communication from the service workers to the relative individual workers for each task. So we moved from like one big monolithic app to this implementation in a big step. It took us a lot of time. But yeah, you should remember that spawning a large number of child Node.js process is not recommended. You can find it on the docs. It can get messy if you have it more than the number of cores the CPU can take. So you should monitor about how much CPU intensive your process is. Now, pros of this approach was scaling is easy. If you have multiple machines, you can easily fork more workers. You don't have any dependency. You are using the built-in Node.js cluster module. It's easy to implement the process communication. You can manage it yourself. But there's also some cons, because you have the dedicated workers. You want to manage them. When they crash, you want to restart them. And you have to also monitor the performance of your overall app. The next thing we did was to have PM2. So what's the benefit of PM2 is that it will, all the implementation we did by ourselves, the for loop, the individual workers, the communication, it will do it for us. So it can auto restart the app if it crashes. You can log the workers, you can check it, you can monitor them. It also provides a key metrics integration. and you can run the Node.js app in cluster module. It was very easy. So what it looks like, that you just need to provide this configuration file. You see on the top, I have the app, which is like the REST app, and it has instance. It's run in the cluster module. It has instance -3. That means max -3. If it's a 4-core machine, you can do it minus whatever you want. Then we have SMS worker, email worker, and instance for one instance of the image worker. This will run at an individual process. So this is what our whole cluster file moved to when we introduced PM2. So you see, we have commented all the code which we later removed, is just to show you. And we just had to deal with the communication between the workers and the master process now. Now, the thing is that as we moved away from the cluster module, we didn't have the built-in Node.js IPC communication channel to send the messages. PM2 does provide it, but it gets really messy. We have to come up with a new solution to manage the communication between the individual process. So yeah, you see the monster is not happy now because we kind of, in a way, to deal with it. And so we came up with RabbitMQ. We were already, some of the engineers were working on this. You can also use Kafka if you need. But the benefit of using RabbitMQ is it's persistent. You can easily manage. There's many exchange types. You can do the bindings. And you can easily monitor it. So we use the AMQP lib package from NPM to manage RabbitMQ Node.js. We use the topic exchange method. There are many exchanges. You can do like fan out, like one message goes to all the listeners. And with the topic exchange, you can manage it for one-to-one and one-to-many communication channels if you need. So just to give you an overview, the message comes from the producers. It lands in the broker. You can have many brokers. Then there's a exchange for each app. We call it app. And then you define the bindings for each type of messages, like SMS, email, image. And each binding gets its own queue of the messages. So the message produced and gets to the queue. This is just a big overview of the implementation. You can get to the more details. So what we did, our whole cluster file, which you saw earlier, turned into just this file. You see, we have the RabbitMQ on the top. On the global methods we defined, instead of process.send, now we use mq.publish. So we publish the SMS, email, and images messages relative to their relative workers. And similarly, on the worker itself, instead of listening process.on, the message, we now use mq.on. So whenever the RabbitMQ receives the message, it can go on. So you see, this became the whole our cluster file, and it was very easy for us to deal with each service individually. Oh, so to give you an overview, these are like app workers, and they are managed by PM2. You can restart them. You can check how many numbers of instances you want. Then we had individual workers like SMS, email, and image. These were also managed by the PM2. And then we put the RabbitMQ in the center to deal with the communication. We have mq.publish messages, which comes in from the apps and goes to the relative workers. So previously, we had the cluster, the master process in the center. And yeah, we didn't also have the PM2. But now you see, we can manage these as separate apps individually as we want. So it became very easy for us to deal with it. Now, there are also pros and cons of this implementation also. You see, the PM2 manages all the process communication and the cluster module thing, not the communication. Communication is managed by the RabbitMQ. The workers itself, and if they goes down, it can restart it. And you can start, stop, restart by themselves if you want. It has a nice commands you can use. And you don't need to deal with the IPC communication in Node processes. The cons of this thing is that RabbitMQ is not that easy to implement in production at first. There's a lot of things you need to take care of. It has many implementations. It has many types of exchange. You need to be pretty sure about what is the best use case for you and which implementation you want to go with. and you need to manage the RabbitMQ server and monitor it by yourself. So from what would be the next steps from after this, after separating out the individual apps? Well, so we can, one thing we could do is that the SMS, the emails workers can be a one service itself. We can call it like messaging service. We can also attach a database to it, and we can move the like mobile numbers and the emails of the users to this service and make it more efficient if we want. We can, like, for the service, with the image handling, we can use Azure function or Lambda. Lambda is one of the best use case for image processing if you want. We can just upload the image to the S3, and then S3 can trigger the Lambda function. We don't need the service itself at all. We can also use the Docker approach. And yeah, we can also use the Azure function and Lambda cloud functions. So for the whole journey, we had like big monolithic app. We broke it down into small chunks, but we kept it in one place. And after that, we introduced the communication channel between the services and the monolithic app through the IPC communication. Next thing we do that we separate them out and we introduce the RabbitMQ, or you can do the Kafka to communicate. And then maybe one of the service or many can go as a cloud function, as Lambda or Azure function. So this was the whole journey. It took us, I think, a year. But yeah, some colleagues and friends asked that why don't you just create a new microservice and run it? What's the whole process? It's like, yeah, maybe you want to try, but don't, because you think you can do it, but you cannot. It's like when it's in production and when you have a lot of clients and users, there's a lot of dependency of each implementation which you don't know. We also thought that it's easy to just run a separate service and manage, but when you go into the process, then we figure out that no, there are a lot of small, tiny dependencies in the app itself. It's not that easy to separate out the implementation itself. You have to also manage with the test cases, the unit tests, and you also want to manage the teams individually so that they can deal with each microservice. And the DevOps also needs to be synced up so that they can manage the services individually. So yeah, I would not recommend any just fast track, just jump from big monolithic to microservice architecture. If you want to do it step by step. So yeah, this is code from Martin Fowler that don't ever consider microservice unless you have a system that's too complex to manage as a monolithic. So it's not recommended. That nowadays we see all the companies and developers talk about let's move to the microservice and serverless architecture, but there's a lot of pros and cons and in the start we don't understand what's right for us. But if it's not too complex for you to manage a monolithic, don't consider it. The microservice itself, it's a big mess if you don't do it the right way. So around this journey, and during the slides, and I gathered a lot of material for this transformation from monolithic to serverless and microservice architecture. I got through a lot of tutorials, blog posts, books, and I tried to gather them all under one blog. It's monolith.io. Nothing is there, but you can subscribe as an email. I'll start posting all the articles and the videos I found during this transformation, and then you can, if you are in the same step, you can follow it. You can also follow it on Twitter. And yeah, that's it from my side. You can follow me on Twitter. They are all on my website. The slides will be available. And thanks for it.